Algebra 1 CP class. I want to just go over the notes that anyone might have missed here today for the standard form, so standard and point slope forms. So we're going to go ahead and these are our goals for the day: to define and use point slope form for a linear equation, define and use the standard form for a linear equation. I first define the standard form. That's ax plus by, where a and b are both real numbers. We like them both to be integers typically as well. I'll talk more about that later. They can't both be 0. If they were both 0, we would have 0x plus 0y equals 0. And we all know that 0 equals 0. That's not a linear equation. So that's why they can't both be 0. We have to put that constraint on them that they can't both be 0. If you look over here next, standard form, we have equations, just linear equations, because I know that both variables are raised to the first power. And I know there is no more than 2 variables here. So I know that's a linear equation. I want to write it in standard form. So I want to get this constant right here. That 9 is a constant. Basically want to get it by itself. In order to get it by itself, I want to get rid of the 2x. So I subtract 2x on each side. That gives me 5y minus 2x. Again, I've already explained this once. That gives me 5y minus 2x, and you'll see why I went back. Minus 2x. And we all know that subtracting 2x is the same thing as adding a negative 2x. Because I add that negative 2x, I can use the commutative property of addition to call that negative 2x plus 5y. Again, this is standard form as well. Understand, we just write as where the constant is first. I say down here that standard form can be ax plus by is equal to the constant, or the constant can be equal to ax plus by. Either one. Down here we have a pesky little rational coefficient there. We'll deal with that later. Right now I just want to get the constant on one side, and I want to get the variables on the other. In order to do that, I'm going to add 5 to each side. That gets rid of that minus 5 over here. So I'm going to put the constant on the left side. In order to do that, I'm going to get rid of that y and take it to the other side. So I subtract y on each side. That leaves me with 2 equals 1/2 x minus y. Now if you remember, I do want it to be plus negative y. So I first use keep change change. Then I would like this to be an integer value. As a result, I'm just going to multiply the entire equation by 2. You'll see why this works on the next slide. When I multiply the entire equation by 2, I'm keeping everything in balance. I'm really not changing the value of the equation. So that's the same as 4 equals 1x plus negative 2y. So some people ask, well, why do we have to multiply it by 2? Couldn't we have multiplied it by 8? Well, yes, you could have. And that would have gotten you 16 equals 4x plus negative 8y, which is the same linear equation. I'm going to show you just exactly why it's the same on the next slide, where you can pause if you really want to look at the work that I did to prove that. Again, negative 3 plus y equals 1/2 x minus 5 is what we started with. Just so you don't second guess me, that was 1/2 x minus 5. So if you look at the next slide, that's the equation we started with. If I wrote that in y equals mx plus b form, it would be y equals 1/2 x minus 2. And understand a rough sketch of that graph, and I should label my x, y axes. I really should. I always want to make sure that the students do it, so I should. And I really should label that as well. Understand that is the point 0, negative 2. But I know that the graph is going to look like this. So I know that that graph is going to hold true throughout all 3 of these. If I start with 4 equals 1x plus negative 2y and solve for y, you can see that I will get the same equation, y equals 1/2 x minus 2. If I start with 16 equals 4x plus negative 8y, and if you want to see this, the proof for this, the proof is in the work. You can check my work. It will check out. I do promise you that. Divide by negative 8 on each side. 1/2 x minus 2 set equal to y. So it's very important that we understand that even though it might look different, all 3 of those were the same linear equation. They just look a little different. This is slope-intercept form. Okay, this up here was standard form. So that was going from standard. So we were going from standard to slope-intercept. And really all we did was solve for y by using inverse operations. It's a very important skill to learn. Slope-intercept form. And in all three of those, that's what we did there. In the next example, I'm going to show point-slope form. But until then, we're going to give you just a short little break here, showing you before showing you point-slope form. I hope you thoroughly understand what standard form is and how to convert an equation into standard form, a linear equation into standard form.